Now, if we're given an angle in standard position, we can use the reference angle to find the 6 trig functions. Okay, to do that, we will calculate the reference angle. 2, determine the value or the values of the 6 trig functions for the reference angle. And then 3, determine the appropriate signs for x and y in the given quadrant. So we will use what we had for the 6 different trig functions. So we'll use the above definition for 6 trig functions to determine use the definition of the 6 trig functions to determine the sign of the 6 trig functions. Meaning if x were negative, then you're going to put a negative in for the value, or if y were negative, then you put a negative in for that value. So, for example, if you were to find, I asked you to find sine of 3 pi over 4. So we know that 3 pi over 4 is in quadrant 2. And if you always forget, where does that stand? You know that straight up is pi over 2, straight to the left is pi, 3 pi over 2 is down, and then 0 or 2 pi is to the right. So where does 3 pi over 4 stand? So 3 over 4 is 3/4, 0.75 pi. So that's greater than a half pi, which is up, but less than pi, which is to the left. Okay, so we are, somewhere over here. Okay, so that's going to be 3 pi over 4. Using what we've learned before, we can find the reference angle. So the reference angle is this angle down here that would make it 180 or pi. Okay, so our reference angle t prime would be pi minus 3 pi over 4. So our reference angle is just pi over 4. Now we know that sine of pi over 4, because we just went over this table, is square root of 2 over 2. And so we look, and this has sine is just dealing with the y values. The y value is positive. So in quadrant 2, y is positive, but your x is negative. So our answer is positive. Now, we'll do another example, cosine, and so therefore, sine of 3 pi over 4 is positive square root of 2 over 2. Now, we'll do another using the same angle, but looking at cosine. cosine of 3 pi over 4. We know already that the reference angle is pi over 4, so we'll look at cosine of pi over 4. In this case, cosine of pi over 4 is also square root of 2 over 2. But cosine deals with a negative number. Cosine deals with x, and x was negative, and so we will add the negative, okay, because cosine of theta is x, but in quadrant 2, x is negative, and so that's why we add the negative in. And now putting everything together, we've already calculated values for sine, cosine, tangent, all the 6 trig functions for 30, 45, 60, but what are the x and y values? Well, we already knew the x value was cosine and the y value was sine. And so, therefore, we could fill out the table. What do all the points correspond to? Here are the angles in either degree or radians, and then your x and y. That's how we got that from sine and cosine in the previous table. So all of this whole table came from this whole figure came from things that we've already calculated. And then again, remember we had talked about symmetry. So 150, 30 degrees is over here. The reference angle over here would also be 30 degrees. And the value is negative root 3 over 2, 1/2, positive root 3 over 2, 1/2. Moving down here, we get positive root 3 over 2 and negative 1/2 because we're below the x-axis. And then in this quadrant, the reference angle is also 30 degrees, 30 for all of these, but we have negative root 3 over 2 and negative 1/2 because that's in quadrant 3. So whenever we calculate trig values, when they are in similar things like sine of 60 or sine of 120, we're going to have about the same value, except there might be a negative depending on which quadrant we're in. But the symmetry that comes across, and maybe this is easier if you look at the radians, because the denominator 3, denominator 3, straight over here, denominator 3, and then denominator 3, they all have symmetry, and so it's just a negative based off of the quadrant that would distinguish things. Okay, and finally, for an angle theta in standard position, let P of x, y be the point on the terminal side of theta that is also on the circle x squared plus y squared equals r squared. So we're no longer dealing with a unit circle, but a circle with some radius of r. Then our 6 trig functions become sine of theta is y over r. Previously r was 1, so it was just y. Y over r, so just dividing by the radius. Cosine of theta is x over r. Tangent of theta is y over x, and again, x cannot be 0. Cosecant of theta is r over y, still the inverse, but we're assuming that y is not 0. Secant of theta, r over x, in this case x is not 0, and then cotangent of theta is x over y, and y is not 0. So now we have our trig functions for any circle, not just a circle with radius 1 or the unit circle.